So, some interested first. My name is Lara Gonzalez. I'm pursuing the reason on Twitter. You can follow me if you wanna. I am very tall, which is relevant because of reasons. I'm a UI engineer at Facebook currently, and I recently left The Guardian to go to Facebook. We are hiring for my replacement still, wink wink, if you're interested. Now, I'm gonna be talking about CSS Houdini, and something I want you to know is that, first of all, this is very self-serving. I picked this talk to force myself to actually understand what Houdini was as a part of CSS. Most of these came from several websites that I stole the content from. And a lot of crowds, like 4 times writing the demos. This is more true of certain areas than in others. But basically, this is incredibly experimental. And if you're wondering how experimental, well, you can just go to caniuse.com and have a look at the Houdini feature set. So one pretty good thing that's more relevant nowadays is that Microsoft Edge is all red and it's not going to exist starting tomorrow because they're going to replace it with Chrome. So that's kind of nice. And as for the other browsers, Firefox has good support, Chrome as an engine has good support, and Safari doesn't really have a lot going on with it, but you know, just pretend it doesn't exist. People with iPhones don't deserve CSS. So I bet you had one sports coach that made you swim on the plinth, no water, before you could swim for real, explaining all the fun of it. Maybe you didn't, struggling to come up with a better relatable idea. But my point is that before we can talk about CSS Houdini, we need to sort of understand what problems it tries to solve and how we got to that point. So the biggest problem that both CSS and Houdini try to solve is that websites exist in the first place, and websites have a lot of problems. CSS is one of them, but not all of them. So, for example, this is a website. As you know, websites do CSS. If we take that, we just get like, this is not working. There we go. This is given, we get like the plain HTML representation. Using CSS, we get like basically a way to turn all this plain HTML into style content. Now, I chose DeviantArt not just because I want to give you a conversation starter for later, but also because DeviantArt is old. It's incredibly old. It gives me very fond memories of the internet 10 years ago when I started developing websites. And it especially gives me memories of all the stuff we used to do as digital artists and webmasters and all the titles we came up for ourselves to bring our ideas on board and to bring them to our browser. So CSS alone has almost always, and we are going to forget about tables here for a second. Just bear with me. CSS has almost always been the tool we have used to sort of take our plain documents and bring them to life. And since the start, we have tried to basically fight against these limitations with a ton of creativity. So for instance, I get super nostalgic thinking about the sliding door technique for tabs, where you had like 2 background images and one of them was very long. Or CSS sprites, or having to choose between Arial and Georgia because those were all the fonts, and there was this completely bananas thing that just replaced them with a Flash movie. And throughout this entire era, we grew this concept of CSS hacks or CSS tricks, where nowadays they are the names of actual websites. And basically, we became very, very good at bending CSS around to do our bidding. And over time, CSS has gotten better itself, and it has allowed us to do more use cases with less of these hacks. And we are now at the point where most of the things we want to do, we can actually do. So it's time to wonder sort of like, where do we actually go from here? Like, what's next after CSS is sort of feature complete? So the interesting thing is that CSS itself is possible, but we are still writing CSS. And CSS is awesome, but it's still just an interface to basically the browser's layout and rendering engine, represented by the fairy. Now, it's pictured as a fairy because there's a lot of magic happening in the middle. And the goal of Houdini is to free, is this working? Yeah. That magic and give you more fine-grained control over what goes on in this middle bit, basically. So the goal of the Houdini task force, the Houdini working group, which gave name to all these APIs, is to build sets of APIs that hand us, as developers and designers, this magic fairy and allow us to actually use it in more advanced ways. Now, you will notice this is not Houdini. This is award-winning actor Jesse Eisenberg. I chose him for 2 reasons. First of all, I love his movies. He has very amazing movies. This was way less weird when I didn't work at this company. Second reason, there is 2 pictures of Houdini I could find on the internet total, on the entire internet. Wait, oh, yeah. And the first picture of Houdini basically looks like a meme. That's like, I don't want to post that. Second one is even worse. He was a script artist. He literally looks like erotica. By the way, not sure if you know this, yeah. So his entire magician deal was that he got trapped in different situations and made his way out of them. Funny. Anyway, I was so intrigued about the Houdini as a name because it's like very specific wordplay. I ended up in the announcement email from 2015, which had a very promising footnote explaining the decision, but then it just linked to the GitHub wiki with the same explainer from the email. So I went ahead and started rummaging through the chat minutes, and 40 minutes later, I wasn't any closer to finding the truth. The cashier at McDonald's was starting to give me looks because I only got small fries while I was writing this talk. But this was sort of my cue to stop this and just accept this silly name. You're not supposed to read a lot into it. It's called Houdini because it's a task force dedicated to letting the magic of CSS break out of its box. Very clever. And before I begin proper, let me leave you with this select quote from my investigation, because what the CSS working group doesn't have in good naming, they have in shade. Now, browser internals are horribly hysteric and only understood by a few people scattered around. Those people don't generally like traveling and talking to people. Back to our web browser. So let's think about some of the things the engine actually needs to do for us to take our CSS, which up until this point Now, these 5 steps, parsing, layout, typography, paint, and animation, are a massive simplification of the way CSS works. They're not like actual stages, they sort of are. And what's really good about them is that they match the APIs that we are going to go over, almost. So basically, parsing is when the browser takes our CSS as the raw text file. And at this point, it could be just about anything. It could be CSS, it could be the 50 Shades manuscript, it could be both because some parts of that are valid CSS, but with the punctuation and whatnot. And this stage is where the browser transforms this into a series of instructions and tokens it can actually understand and work with. Next, we have layout. And layout is how we define box models for our element. It's the sets of APIs that lets us move stuff around the page and out of their normal text flow. When it comes to writing CSS, this is things like floats, display, position. And now this is great, but if you've ever used Canvas or a game editor or are looking at the slide, you will notice the text is kind of out of whack. To fix this, we got to take the text and actually lay it out so it fits in its boxes. At the end of the day, this is also layout really, like the words are smaller boxes. But since words are very important, browsers and operating systems expose a lot of control and complexity about this. It's why the list of things you can think about font rendering in CSS is almost endless. So next, we probably want some color, and everything in CSS from backgrounds to borders and underlines eventually has to find some pixels on the actual screen and paint to them. And this is like the painting process, and this is also one of the most usable Houdini APIs today, so it's one we are going to go in detail. And finally, we might want to move things around like that. The browser is doing a lot more than animation at this stage. I suppose we can consider this the whole compositing stage too, where we turn everything sort of into layers with the GPU. But this is a lovely outline, and honestly, it gives me all the APIs I want to talk about, and it gives me a super seamless transition if only I hadn't talked about it. So this is where we are at today. Now, until the Houdini task force came along, we had no way to actually influence or understand the browser decisions that went from the CSS to the pixels on the screen besides using CSS itself. And the goal of this task force is to expose APIs that let designers and developers gain a bit more control over all the internal aspects of this rendering layer. So these 5 are part of the initial work, but it's by no means finished. And these APIs work together, and some are less impressive than others. And some APIs make things animate and fly and stuff. And some are just like TypeScript for CSS. Let's move on to that one. So the typed object model is boring, but basically it's a new set of APIs that let us retrieve and set the style properties of an object as their actual values instead of by passing a string. So this is great for performance reasons for the browser, but also instead of help us get away from trying to compose CSS when we're using JavaScript as sort of strings, like we are doing some sort of SQL injection here, and instead we can use proper values. This lets us bypass the entire text parsing layer of the browser, just feed it values directly. So yeah, basically you don't have to do stuff anymore. You can talk directly to the browser. There's also type variables, and what this lets you do is the same thing as type programming in general. It gives the computer more hints about what to actually do with this value. And in the case of CSS, it allows us to do things like animate from a color to a color, because the engine now has enough time to actually figure out that this is a color going to a color and it's safe to animate. And basically, by letting the browser know what to expect, can optimize these things. So, 1 second. So for instance, the most typical example for this is setting the values in a CSS gradient to type variables. Just by doing that, you can now animate CSS gradients, which seems to be like the most common example. And my friend Oliver, who runs the London CSS Meet-up, did this example for me. So I'm just gonna walk to his website and show it to you. I can't remember how to quit, just. He made this website about Jeff Kaplan. And the important thing here is that you can, well, there are so many important things going on in here, but for the purposes of this, it's the background gradient, you can notice it's actually transitioning and animating super smoothly. And when it actually comes to the CSS, it literally only has background from a variable to a variable, and they're being updated on the HTML tag. Let me make this a bit bigger for you all. And this is all the JavaScript involved. All the animation is handled by CSS now, thanks to all this variable magic. That's pretty cool. What would be cool? A usable way to switch screens on a Mac. Now, when it comes to layout, there are basically like 4 basic types of CSS layout. You get your inline layouts, which is like when things go next to each other. You can have block layouts, which is when things go stacked on top of each other. You can use flexbox to better define the way set of boxes go side by side with each other. And finally, you have CSS grid, which lets you define how boxes stack together. And you would think this covers pretty much every layout you could possibly really want, but then Pinterest had to come along and make this. And I think all of us have had to make this. Somebody decided it's called masonry. I hate it. And this is basically the primary example of layout worklets. It's like the animated gradient of layout worklets, and with good reason, because this is not something easy to do on CSS. So traditionally, please tell me if there is a better way, by the way. Traditionally, I would just make everything absolute and calculate the position with JavaScript, just put it on the page. Please, actually, show of hands who has made this. Yeah. Beautiful. But the point, I guess the point is we have had to take the layout the browser already calculated for us, and then we had to use JavaScript to basically draw another layout and then make everything absolute and do a bit of back and forth with the browser to calculate the final heights and whatnot. But now with the layout API, there is a better way. So the layout API runs on worklets, and a worklet is basically like a web worker, but for CSS. So normally our JavaScript runs in the same thread, and our code totally blocks the page. And worklets, just like service workers and the other one, are parallelized by default. That means that instead of just running our code, the browser sort of passes it on to another more specialist part of the engine or a thread. So it just takes it on, And what this means for us is that unlike normal JavaScript, we are limited in things like accessing window or the DOM because the JAS aren't there. Now, this separation of concerns in the design is what allows us to be thread. It also allows it to be a pain in the ass. And it's a bit scary, but if you've ever done a Chrome extension, this is sort of the same deal. You basically have to orchestrate a bunch of different files talking together. What this allows basically is for massive performance gains. So instead of just moving and shifting stuff around the page, we can actually tap into the browser's layout engine at the point where it has to lay out these boxes on the page in the first place and do things right on the first go. We are not doing that for a demo because that's very hard, but let me show you a small flexbox. This is why my tallness is relevant. This is, let's see. Bear with me because I'm gonna have to make a little live coding. So I've got layout here. So I've got this. This is a card from an app that shows you movies or whatever. And what I've got going on right now is nothing. This is just what the browser gave me. I've got these elements. Page 2, which is a blog, a small. However, on the CSS, on div class layout, I'm going to add, if I haven't already, yeah. And I'm adding this display layout center. What this references is a layout that I have defined in my worklet. So this is all works in conjunction. And as far as my CSS, as far as the browser engine is aware now, I'm doing the layout for everything inside this box. So if I refresh the page now, it's basically doing nothing. It's placing everything on the top, which is, honestly, it's kind of aesthetically pleasing, but it's not what we want in this case. So what? So let me copy this real quick. So when we register a layout in our worker, this is a lot. First I pass it the name, and then I've got this class. And there's a lot going on with layout, but today let's focus on something very simple. So I can get the width, and this is the inline size. I can get the height, and this is the block size. And this is a function that's going to be running on my parent. And then I can iterate through my children. And then what I can do basically is, let me real quick. Yeah. Yeah. So I've got this object with children. What I can do is I can define their inline offset and float offset. And this is all very fancy terms, and this is available on the internet. But just to do something simple, let's do a flexbox real quick. So what I'm doing here is I'm taking all of my height, which I know here, and I'm subtracting the inline size of this fragment. And then I'm dividing this by 2. What I'm getting now is that all my elements are centered. And this actually messes up the Chrome inspector a bit because it doesn't quite know what's going on. Like I'm no longer respecting this margin, for instance, because I haven't implemented it. And now you might be able to notice that we are still sort of run into this problem where all the items are on top of each other, but we know their height, right? So something we can do, don't tell my boss I code like this, we can just keep track of the height of each element. Let's do an offset 0, and then we can do a block offset, and our block offset can be the available block size, again, of the box, and that's going to center it. And then we can subtract the size of this block. And then basically at the end of it, we want to add our offset. And then we add the size, the height of the element to the offset. And this is all a very fancy way of saying that for each element, we are taking the height and we are we are taking the height of all the previous elements put together, and we are adding that to the vertical offset of this element. What this means basically is that now we have everything centered, which is nice. However, and you can't see that on this projector, so let me add a border around this. Everything is centered, but it's centered relative, like it starts at the top, right? So it starts smack in the middle. That's not entirely what we wanna. What we wanna is, after we are done with this, something we can do very easily is go back, and for each fragment, again, we are gonna subtract the entire offset, and that's gonna center it. And now you might be wondering, well, that's kind of useless. We can just do a flexbox. You're right. You're completely right. But something kind of cool we can start. Imagine this was a more complex layout in some way that escapes me. Imagine, for instance, that we want to add a user customizable gap between the elements. That's not actually implemented for flex layouts for some reason that eludes me. But by using this layout that we have built, we can very simply define in our class that we are taking a gap variable as an input property. And this is just boilerplate, really. But basically what we are saying is we are sending back an array of CSS variables that we want to take as input properties. And we could type this using the typed OM as well. And now that we have that sorted, well, we can grab our gap in this calculation we had before, and we can just add it here to the block offset. Whoops. And now what's going to happen now, which is kind of cool, is that from the CSS itself, if I edit my gap variable, absolutely nothing is happening. So give me a second. And now we can separate these elements as much as we wanna. So again, kind of cool, like not the most useful case, but you can imagine how with more powerful layouts, for instance, if we were doing a full-on masonry layout, this would be a very powerful way to make it customizable in the end. We can also just break the entire thing at a negative gap, or I haven't typed these variables to do this. And it's gonna kind of still work, but not really do what we wanted. And that's basically layout in a nutshell. Now, going back to the presentation. Yeah. The next thing we've got is typography. And this was actually, I was so excited when I was reading about this, because as I said at the start, I used to work at The Guardian. And you may have noticed that The Guardian does a lot of fancy stuff with typography, including somehow getting The Guardian in like 3 different types of capitalization in the same page. But until I joined, I thought, CSS is good enough. There's nothing you can't really do with CSS anyway. I was a naive fool. Still am, just saying I was. We are doing very fancy stuff. And I want to point out 2 very specific things we are doing with text right here. So in this case, we have this very fancy underline going under the words. And the way we do this is a CSS gradient mapped to pixels that sort of depends on the line height, and that's like a house of cards waiting to fall. And the second one is a bunch of spans breaking the word. So something like, why is this? Anyway, a bunch of spans behind the word, just adding the background color. Very, very common hacks, I would say. But the thing is, they're both a bit hacky, and we don't have perfect control over them. So, for example, we can't really cut this when we run out of space, when the word ends. Or we can't really, there was something we couldn't do with this, but it's not important. Now, what's really important is that what would be really cool here is to have something like the typography API that would basically allow us to get metrics on the text and metrics on the words and know the exact pixels where the words are being drawn. So we could actually decide where to put things like underlines and whatnot. Now, sadly, it's actually not being developed by anybody. And I just realized this when I was writing the talk. And I also realized that the proposal is actually 4 years old. So I don't think that's going to happen, but I want to leave you with some of the other things that were happening 4 years ago. Now, the main reason I'm telling you is because it's still supposed to be on track, and when it comes along, it will hopefully be awesome. And in the meantime, if you want to use it today, you can play with React Native, which has a very similar API, and it rocks for doing stuff like text. And that's typography. Keep an eye on it. It's going to be awesome at some point. Next up is Paint. Paint is cool, both the app from Windows and the Paint API. Paint is like the biggest part of Houdini by far. I said before, since the dawn of time, we have aspired to use CSS to draw random shit on screen. And for years, we constantly attempted to one-up each other in a very wholesome display of ego. And at some point, things got good enough, we sort of forgot, like we don't need CSS font. Like, we don't need a blog post about doing CSS fronted corners in all browsers with no images. Also, funny story, the Opera logo used to have a shadow with gloss on it, which is like the most 2000 thing ever. But even today, there are things we do that are too complicated. Like, for instance, sometimes we have form inputs with a ton of helper divs, multi-background compositions, whatever theme we are doing now to do those little arrows with the speech bubble. Personally, use the border. It's very nice. And we've gotten used to all of that being normal, but maybe there are better ways. Like maybe the best way to draw a cover is not to chain 3 divs together, and maybe the best way to style a checkbox is not to nest it with before and afters until we get sick of it. So the idea for the Paint API is that now basically we can draw backgrounds with JavaScript. This is how it looks like. The CSS API is deceptively simple, and it looks kind of, it's important to remember that just about everything can be a background in it. So here's the JavaScript side, and this is a worklet as well, and we will go into an actual one in a bit. But I've chosen the shortest example I can think of because I don't want to bore you with code. So basically what we are doing here is we know the width and height of the element, and we are just filling it with red. This is a canvas. And what's really cool is that there is a lot you can do with a canvas. And you can also take arguments. So you can get input arguments like this, and you can pass this to your Paint function, or you can also pass them as variables, and this is all composed with each other. And what's even more powerful is that if you pass this as variables, this is a worklet, it's hella fast, so animation just works out of the box. And let's have a look at that because I haven't crouched enough. So I tried really hard to make something that's not also a gradient, and I came up with this shape. It's a circle with holes in it. Now you will notice there is nothing going on, it's just a div. I made it round by setting the border radius, clever me. And what's really cool, I have this background, Paint. See, that's the entire thing. And if we are to go into the JavaScript, by the way, how are we doing time-wise? Okay. This is like the last convoluted demo, and then we are good. If we go here, I'm registering these properties just for the sake of being fancy about it. So I'm registering a property called PG, property called dots, and a property called radius. And I pass those onto my Paint worklet. So for instance, let me show you. If I want to change the radius of my inner circle, I can just pass it as a variable, and it animates. which honestly is actually pretty awesome. Same if I want to change the background color. So I think I've got background and I've got dots because I'm terrible at names. But if I want to make dots red, I can do that. And something kind of cool that maybe is like the only thing I could think of that you can't do with CSS, but then I learned that you can anyway, is we can also draw transparency. So if I go to my worklet and I just copy this. So well, first of all, this is a canvas that draws dots. This is like a checkerboard pattern going on right here. If you're more curious about canvas, let's hope for another talk about it. But what I want to show you is that we can also draw transparent dots, which is something you don't see commonly in CSS, mostly because this is kind of disgusting to look at. If you want to do this, you can use a clip path, by the way. Don't do this. But you know, we have a background that's dynamically generated and that we can animate. Okay. And we didn't actually have to write this animation. We can also apply curves. And it just builds on top of the CSS APIs in a very natural way. And that's basically Paint. And you can imagine how you can use it for just about anything. Now, back to the slides. So, next up, animation. Animation has been around a while. We've done animation for a long time. What the animation API lets us do is basically two very cool things. First, we can define our runtime functions. So is in, is out. We can define those as JavaScript. And we can define exactly what the is in and what not looks and feels like. And the thing is, if you're into that, you can get very fancy. If you're not into that, other people are doing it for us. So that's awesome. And secondly, it provides more performant ways to define animation via JavaScript. So the way animation normally works in JavaScript and in CSS nowadays is either you have static animation set in your CSS file, or you use JavaScript with request animation frame and you just update the CSS every single frame. And that works because we have $2,000 computers. And third, which is very cool, and I want to show you today, there's a new API that gives you the scroll position, and we can finally do fast parallax scrolling. And that's the new way to do fast parallax scrolling this year. Seems like every year we come up with a new and faster way to do this. I fondly remember when the Chrome team was like, hey, you should actually make it parallax with the transform to the API. That actually worked, but it was completely horrible. It was very fucked up. So let me give you a quick demo of animation, and we are not going to go into detail about so. Oh, you have seen nothing yet. Let's see. Let's have a look at the code first. So in my animation worklet, what I've got is basically, I'm doing nothing. This is linear. I give it a name because I'm a moron, but this is a linear animation. And then inside of my code, what I'm doing is a bunch of boilerplate, and then I'm registering a worklet animation and a keyframe effect. And keyframe effect is the new API that I'm kind of excited about. It basically, no, the work animation does, whatever. To work at animation lets you define a start point, an end point, and then you can pass it a timeline. And this is where it gets interesting. Notice that at no point we're actually like going in manually, using request animation frame and doing all of this. What we're doing instead, it looks closer to traditional CSS animation, where we have a start point and an end point, and we let the browser take care of this for ourselves. And the way this pans out in reality is that we get incredibly fast performant animation. So for instance, we can do this. And the thing is, you can do this nowadays with request animation frame. It's going to be just as fast. But what if you scale it up? What if you have several JSs? And this is animation, basically. Cool. So to sum up, we've got the type object model to define CSS variables that actually have types in our performance. We've got the layout API that lets us do the Pinterest masonry layout, and I'm sure somebody will come up with something different to do with it. We've got typography with there is no typography. We've got paint, which should allow us to at some point start drawing things instead of JavaScript, instead of using a bunch of CSS position hacks. And we've got animation that, on a more serious note, it's an amazing tool, even today, to do fast and performant animation that mostly it's not just fast on our computers, but also it's going to be faster on lower-end devices, which is always nice. And what's more important in a higher level is that the goal of Houdini task force is to expose even more APIs that allow designers and developers to gain a bit more control over all these internal aspects of rendering. So these 5 are like the first artifacts they have come up with, but there is even more on the way. If you look at the original email, you can sort of get an idea of the present and future scope of this and get hype. So you can already see things in work like input extensions to this current pointer. You can imagine you will be able to extend the box tree. You will be able to do new CSS selectors. It's a very exciting future. And basically, Houdini lets you poke the engine that powers CSS. And in the future, you will be able to write your own polyfills and decorations with less hacks. Now, something I noticed while writing this talk is that basically Houdini is a bit like the web components of CSS. And then this actually makes me feel conflicted, not just because I cannot work for the people who make React, but you see, for years, evolution in CSS has remained in the realm of CSS. It's an incredibly easy, incredibly approachable language that lets you do a ton of things with very little code. It has empowered a lot of beginners, including myself, to start making websites. Like I myself mastered HTML and CSS, okay, mastered, if you know what I mean, when I was like 15. I was very young, but I already had a very firm grasp of HTML and CSS before I started even daring to go into the JavaScript world. And I have talked before about how cool it is that we can just use a canvas instead of some clever div soup in order to render a checkbox, how we can just write our animation in JavaScript instead of CSS. But something that worries me is that the end game of Houdini is to take all these messy and ugly hacks, all these incredible feats of creativity and ingenuity, and with Houdini, they will just go away and they will be replaced with purer, cleaner code that is not as welcoming. The part of Houdini that APIs that actually touch CSS is deceptively simple. Just like with web components and like on my kitchen cabinet, you can argue it hides away all of the complexity in the background. And something that worries me is that if the future of CSS is finally here and the future of CSS is JavaScript, we might have just accelerated the end game of JS and CSS solution, but the other way around. We are still writing CSS, but we are delegating the complex bits, the hard bits, to way more complex JavaScript code instead of trying to do it in CSS itself. And oh boy, people have strong opinions about CSS in JS. I really don't get it. It's just a different syntax of the same language. This is vastly more radical, but oh well. On a happy note, and thing is, I had to write a lot of JavaScript for this talk, and I do this a lot, but normally for work, it's just like React and TypeScript, Redux stores, and the JavaScript you actually write here is not like that. It's fun. It's engaging. It's almost like writing CSS with JavaScript. Drawing canvases is fun. Laying out boxes is fun. And looking at this again, it's important to remember JavaScript is open source by default. I can totally picture 15-year-old me getting an interest in JavaScript at all, at first, just because these lines of CSS are clearly doing more than what we're actually expressing here, and I want to understand that cool stuff and make it my own. So here's my happy note. Houdini makes JavaScript magical. Now, writing this has brought me back so hard to the days of mootools and jQuery and stats. And I'm super excited for all the cool things we will be able to build with this and share and reuse with the world. And yeah, thank you for listening to me. I will post the slides on Twitter, and you can check out all these demos in Houdini Playground.netlify. Sorry, not Catchley, but my website.